We're going to work on epoxidation of alkenes. So we have our alkene right here, and we have a peroxy acid. The way we know it's a peroxy acid because instead of being COOH, we have an extra oxygen right here. We have COOOH, so that's a peroxy acid. And we should expect this to yield an epoxide plus a carboxylic acid. Now for the mechanism of this, it's all a concerted step. We know that this is an oxidation. We got to remember that oxidation is when we add C bond N or C bond O or C bond X, X being the halogens, or if we lower the number of CH bonds. So this is a clear oxidation. Now, like I said, it's all one step, and our main focus is that the bond between the oxygen and the oxygen, this bond right here, that is a weak bond. So what we're going to do is this oxygen right here, it serves both as a nucleophile and electrophile. That means that it's going to accept the electrons from the double bond right here, and is going to attack this carbon right there. So this is the two bonds that we observe right here. Is one getting the electrons, and the other one it's forming a bond with the carbon. Now this bond, we said it's weak, so we expect it to break, and it's going to come, it's going to make a double bond with this carbon right here. Now we have a double bond right here. That means that we have a sigma bond and a pi bond. Out of the two, the pi bond is the weakest bond. So the pi bond is going to break, and it's going to pick up this hydrogen right here. And this is the OH that we observe in the product. So overall, we have this oxygen, it picked up the bond from this one right there, and it attacked the carbon, which is this bond that formed right here. You see this R, it goes to R, and the rest is the same. And then this bond, which is oxygen-oxygen bond, is the weak bond that breaks, and it allows us to have two molecules again. And it goes to a double bond. That means that this oxygen right here is this oxygen right here. You have your double bond C. Then you have your R prime. And then this one, it breaks the pi bond by picking up this hydrogen. And that's the hydrogen you see right there. Okay, so let's see an example of that. So we have our alkene here. Then we see that this is a peroxy acid. It has the double O, triple O actually, and the H. So we expect it to get to an epoxide plus the carboxylic acid. So the way I'm going to do this is I'm going to show the double bond clearly, the carbon-carbon double bond. So there it is. Then on the top, I'm going to write my R group, which is a CH3. Then on the bottom, I'm going to draw my H, this H right here. Then this carbon has two H's, so I write them like this. And now, this molecule, I'm going to draw the weak bond, the oxygen, weak bond. We said that's the weak bond, which is this two. Then I know that there's a hydrogen right here. I know that down here, it attaches to a carbon. Then I know that there is a double bond O. So I'm going to draw the double bond that way. And I'm going to draw my R group right here. CH2, CH3. So now the mechanism comes. Remember, this is all one step. It's a concerted step. I know that I have a weak bond right here, so I could even start by transferring this bond right here and making my double bond. I know that this double bond, there is the pi bond that is going to break and is going to pick up this hydrogen. So I know that this bond has to go somewhere. So what's going to happen is that this bond is going to attack this carbon, and then this carbon, or this double bond, is going to attack the oxygen right there. So if everything was done right, what we're going to do is, let's draw the carbon-carbon double bond. We got carbon-carbon double bond. And now, the R didn't change, so we have CH3 up here. We have our H right here, an H up here, and an H up here. Now we know that this bond disappeared. So what we're going to find is an oxygen right here, and these two bonds that were formed by these two arrows. Now, my other molecule is going to be my carbon-oxygen bond. So I'm going to draw it here, carbon-oxygen. We know that this oxygen picked up the hydrogen, so I'm going to draw it right here, H. Then I have my R group right here. I'm going to draw it, CH2, CH3. And then I know that this made a double bond with the oxygen. So I have double bond oxygen. So this molecule is that one up there, and this molecule is that one up there. Okay, another example for this. So we have this molecule, our peroxy acid. Our expected product should be an epoxide and a carboxylic acid. Now, let's try this out. We have this molecule, so we said that the carbon-carbon double bond, we're going to make it that way. So I'm going to shift it a little. There you go. Now remember, it doesn't really matter. This is a cyclic compound, so it doesn't really matter where we write it. It's always going to be between 1 and 2. But just for visual purposes, I'm going to draw it like that. Now, we said that our weak bond, the oxygen-oxygen bond, is going to be right here at an angle. We draw it. And then we said, okay, this oxygen has an H. And then this is attached to a carbon. Then the carbon has a double bond, O. And it has the R group right here, CH3. So just to make it easier on yourself, remember that the double bonds are the ones that go straight, if you want to think that way. So now, it's a concerted step. We know it's an oxidation, so let's make the mechanism. We know that this oxygen is going to act as a nucleophile and an electrophile. That means that this bond is going to break, it's going to attack the carbon. That this double bond, the pi bond, is going to break, is going to attack the oxygen, that way. So we know that this hydrogen cannot stay like that by itself. So this double bond is going to break. Remember, the pi bond is the weakest of the two. If we have a triple bond, you have 2 pi bonds and 1 sigma bond. So the easiest ones to break are the pi bonds. So the pi bond in here is going to attack that one. And then our weakest bond, the oxygen-oxygen bond, is going to form a double bond right here. Now, let's draw how this is going to look on the product. So we know that these two carbons are making a bond with the oxygen. So that's the first thing I'm going to draw. I'm going to draw my cyclic structure, like that. And then I'm going to draw the oxygen, which is this oxygen, and the 2 bonds that I just formed. That one and that one. Now, I'm going to draw this carbon So plus the carbon right here. Now, we gotta remember that the double bond is formed with the oxygen that goes to the top. So I make my oxygen here. I write my R group, CH3 here. And this oxygen picked up the H. So I draw my OH right here. Remember, it's all one step. It's a concerted step. You don't have to worry about charges. And that's that.
All right.